Why colossal squids are terrified. With a colossal squid, no scientist can prove that it feels terror the way a human does. But evolution leaves evidence. And in the colossal squid, that evidence is written into the largest eyes in the animal kingdom. Eyes seemingly built not simply to find prey, but to detect one enormous shape approaching through the darkness. That shape belongs to the sperm whale. Far below the Southern Ocean, sunlight fades into blue, then gray, then nothing. At several hundred meters, the world becomes a cold black volume with no horizon and almost no landmarks. Here lives Mesonychoteuthis hamiltoni, the colossal squid, the heaviest known invertebrate on Earth. It is not the long, delicate giant squid of sea legends. The colossal squid is shorter, broader, and more heavily built. 8 arms surround a hard beak. 2 feeding tentacles end in muscular clubs armed with rows of swiveling hooks. Once those hooks catch flesh, they can rotate as the victim struggles, helping the squid maintain its grip from changing angles. In 2007, fishermen in the Ross Sea hauled up the most famous specimen ever recovered. It had attacked an Antarctic toothfish already caught on a long line and refused to release it. Frozen, the squid weighed about 495 kilograms, though researchers later estimated its true weight closer to 470 kilograms after accounting for ice. Even then, the animal was not considered fully mature. For almost a century, this species was known mainly through fragments, damaged bodies caught by fishing vessels, isolated beaks, tentacles, and remains recovered from predators. Then, in March 2025, a remotely operated vehicle finally recorded the first confirmed colossal squid alive in its natural environment. It was only a juvenile, about 30 centimeters long, drifting 600 meters beneath the South Atlantic near the South Sandwich Islands. The adult remains almost unseen. That absence has allowed mythology to grow around it. With hooks, a crushing beak, immense eyes, and a body approaching half a ton, the colossal squid appears designed to dominate the abyss. But its real strategy is less like a charging monster and more like a living trap. The water around Antarctica is brutally cold. In that environment, the squid's metabolism runs at an extraordinary low rate. A scientific model estimated that a 500-kilogram adult might require only about 30 grams of prey per day to sustain itself. It does not need to race constantly through the water. It can conserve energy, remain nearly motionless, and wait. A fish passes close. The tentacles launch. Hooks rotate into position. The prey is pulled toward the arms where the beak cuts into flesh. For most animals in this darkness, that attack may arrive without warning, but the colossal squid is not alone at the top of the food web. Something much larger regularly descends from the surface to hunt in the same depth range. A mature male sperm whale can weigh tens of tons. It is the largest living toothed predator, an air-breathing mammal capable of turning a region of the deep ocean into a hunting ground. Typical foraging dives last around 40 to 50 minutes and often reach between 400 and 1,200 meters. Some dives go considerably deeper. Before descending, the whale fills its blood and muscles with oxygen. Then its tail rises, its body angles downward, and the surface disappears above it. As pressure increases, its flexible chest allows the lungs to compress. Oxygen stored in blood and oxygen-binding myoglobin inside the muscles keeps the body functioning. The heart slows. Circulation is prioritized toward essential organs. The whale becomes a controlled biological diving system, carrying a limited reserve of surface air into a world where breathing is impossible. But surviving the depth is only the first problem. The second is finding prey in total darkness. The colossal squid answers darkness with enormous eyes. Measurements and modeling suggest that giant and colossal squid eyes can reach roughly 27 centimeters in diameter. For ordinary visual tasks, an eye that large is inefficient. Beyond a certain point, increasing eye size provides little extra benefit for spotting small prey. But there is one task for which enormous eyes may be uniquely valuable: A sperm whale moving through deep water disturbs microscopic organisms. Some of those organisms produce bioluminescent flashes. The whale may therefore announce its approach as a faint moving cloud of cold light, a huge outline revealed indirectly by the glowing water around it. Researchers modeled that a giant squid eye could detect such a disturbance from roughly 120 meters away. That may sound like a generous warning. In the abyss, it may be only seconds, because while the squid is trying to see the whale does not need light to see the squid. Inside the sperm whale's massive head is the most powerful biological sonar system known. Specialized structures generate intense clicks and direct them forward through the tissues of the forehead. The sound travels through the water, strikes objects, and returns as echoes received through fatty tissues connected to the lower jaw and inner ear. Each echo carries information: distance, direction, movement, the contrast between a squid's body and the surrounding water. During the search phase, the whale produces regular clicks separated by fractions of a second or several seconds. It is not shouting randomly into the dark. It is repeatedly sampling the space ahead, adjusting its movement and acoustic attention as it searches different layers of the water column. The squid can hide its color, but sonar does not care about color. It can release ink, but ink evolved mainly to confuse vision and chemical senses. It can freeze motionless, but its body still reflects sound. The whale does not need to see a silhouette, it only needs an echo. Then the pattern changes. As a sperm whale closes on prey, its slow clicks accelerate into a rapid sequence called a creak or terminal buzz. Tag studies have linked these bursts to prey capture attempts. The shortening interval gives the whale faster updates as the final distance collapses. Imagine the encounter. A colossal squid hangs almost weightless in the black water. Its arms are folded near its body. Its tentacles wait like loaded cables. Around it, there's nothing visible beyond the small particles passing through darkness. Then a dim shimmer appears above. Not a single light, but a moving disturbance. The squid's enormous eye gathers the few available photons. The shape behind the glow is too large to be prey. It is descending, and it is already facing to the squid. The whale has been clicking for minutes. It has already separated this target from the background. The regular knocks tighten into a buzz. The squid moves. Its fins pulse. Water jets from its mantle. Its body changes direction, but the whale's echoes return again and again, updating the chase. The squid may turn sharply. The whale rolls and follows. The squid may spread its arms and prepare the hooks. But the approaching animal can outweigh it by more than 100 times. At contact, the squid is not helpless. Its hooks can tear skin. Its suckers can lock onto the whale's head. Its beak can cut. Circular scars and other marks found on sperm whales show that large squid do fight back. Some whales carry pale patterns across the head and jaw for years, permanent evidence of encounters no human witnessed. But scars are not victory. The most direct evidence of the relationship is found inside sperm whales. Colossal squid beaks have repeatedly been identified in their stomach contents. The beak is made from material resistant to digestion, so after the muscles, skin, and organs disappear, it remains as a record. This relationship is so old that science first described the colossal squid from remains recovered from a sperm whale's stomach. Before humans saw the intact animal, they knew it through the predator that had eaten it. There's no need to claim that the whale's clicks paralyzed the squid. That famous idea was tested, and tag data instead showed whales actively chasing prey while clicking and buzzing. The truth is more impressive. The whale does not require a fictional sonic weapon. Its advantage is detection, pursuit, size, endurance, and control of three-dimensional space. The colossal squid's greatest defense may be early warning. Its giant eyes can reveal the luminous wake of a large, approaching predator, but the sperm whale's sonar can search through darkness without waiting for anything to glow. One animal evolved to notice danger sooner, the other evolved to make darkness irrelevant. This is why the title is not really about emotion, it is about evolutionary pressure. Generation after generation, the squids that detected whales sooner had a better chance to escape. Over immense spans of time, selection favored eyes unlike those of any other animal. Those eyes are biological evidence that something in the deep was dangerous enough to justify their enormous cost. Yet, the predator kept its advantage. The colossal squid belongs to an ancient lineage that entered the oceans hundreds of millions of years before whales existed. The sperm whale descends from mammals whose distant ancestors lived on land. One animal was shaped by the abyss, the other invaded it. And the invader learned to hunt without light. Every sperm whale dive begins with a breath taken beneath the open sky. The whale carries that oxygen downward, passes through the final traces of sunlight, and enters the squid's world. There it switches on a beam no eye can block, follows echoes no camouflage can erase, and turns one of Earth's most formidable invertebrates into prey. The colossal squid has rotating hooks. It has a powerful beak. It has the largest eyes known in nature, but somewhere in the darkness the clicks are getting faster. And by the time the squid sees the glow, the sperm whale may already know exactly where it is.